side, ne?
It's fine.
And then you want me to share the slide?
Yeah, I will just talk from here. Share the slide from your side because it's taking time.
Okay, let me share the slide from my side. Where is it?
So you will just be pressing the arrow to say it can go on, it can go on.
Okay, sharp. No problem. Let me share the screen. Where's my screen? This is the slide, right? Share.
Okay.
Can you see my?
Yes, I can. Start from the beginning.
Okay, let me see.
It's better like this. Do it from your side. Let me go with the phone. It's fine. It's taking time. See, my screen is black out already. Okay, go from the beginning. Are you recording? Sharp. Make sure it's recording. Eh? Make sure it's recording.
Yes, it's recording. So sharp. We can start now.
Okay, good morning. Hi. Okay, so I'm here. I'm Peace. The team Peace and CK, we are here to present to you our digital forensic investigation. So the investigation is on a bank, ABC Bank. Next slide, please. ABC Bank, and we used the environment, Python and Jupyter Notebook. So from this code that we use in doing this investigation, 40% of the code is ours and 60% was AI generated libraries. Okay, next slide. So our introduction, we realized that on the system logs of the ABC Bank, we found 492 frauds out of 284,807 transactions that occurred on the bank. And on that 2 days transactions, and we had some features on the system logs that had time, which showed the transaction that happened consecutively and the amount that showed of the transaction, and even the class that showed both the fraudulent transactions and the legitimate transaction. Next slide, please. Okay, so we went on to start with our incident overview. We tried to understand what happened, that the bank, the customers complained of unauthorized access charges that occurred on their bank transactions. So we were called upon to investigate what actually happened. The next one. So the purpose of this investigation is to detect anomalies in the credit card transaction and to gather evidence that would support the legal actions of the reporting of the incident. Okay. So we used data analysis methods to do this investigation, and then we had to understand the log analysis and the user activity analysis of the system logs. Okay, next one. So we collected the evidence using the system logs of potential compromised servers. We also did server logs as well. We also did the users' activity logs of the transactions that occurred on those 2 days consecutively. Next slide. Okay, so we used preservation techniques to preserve the original data sets. How did we do this? We used write blocking techniques so that the data will not be altered. It will remain original as it was given to us by ABC Bank. So we also secured the dedicated forensic servers that was used for the investigation, and we created a chain of custody documentation to maintain the evidence integrity. Next slide, please. Okay, so this is to demonstrate how we used AI capability on the investigation. We did anomaly detection where we used libraries like the TensorFlow, Keras, sklearn, OpenCV to detect anomalies which were identified. You will see it later in the slide. We also did visualization and reporting where we now showed the monitoring of the network traffic, and we also showed the log analysis of the traces of unauthorized assets that occurred in the bank. Next slide, please. So you see from that graph, you see the changes in the time that occurred. We also did log attempt analysis showing, you see the red dotted line as the fraud that occurred in that transaction, while the blue dotted were the legitimate users. So you will see that lots of frauds occurred that day, and that's why they escalated the investigation. Okay, next slide, please. So next slide, please. So we would see from here the user activity analysis that sometimes it fluctuated. Failed login attempts happened. It was high, like you see on the 10th hour. Also between the 20 and the 30 hours, you also see another high failed log attempts, meaning the attackers were trying to log into this user's transaction account. Okay, next slide, please. which showed that there was fraud occurring. So our findings and analysis, we showed visualization graphs of anomaly detection. You see the intensity of the anomaly detection, unusual behavior that occurred. So down there is the more intense, from the negative value 1, -1, down to -4, show the intensity of the anomaly detection. And you also see on the clustering on the right as well, you see the clustering that there's a red on the extreme left that showed that there was really an unusual behavior that occurred. But still, the dark blue part also shows that there were anomaly detection. So it shows the intensity of how serious the fraudulent act occurred on that transaction. Okay, next slide, please. So the potential impact of this happens to be that we have two classes. We have the class 0 that shows that there were legitimate users and there were non-fraudulent activities, but the class 1 showed that there were fraudulent activities. So you would see that the legitimate users were more, but there are little of the frauds that happened, just like it showed you on the red dotted lines. The same thing is showing here, that there were potential impacts on that transaction. Next slide, please.
Yes, thank you so much, Peace, for the first half of the presentation. I'll take it from here, Hetepe here.
Thank you.
So,
okay.
What my colleague just presented to you as an overview of the digital forensic processes, right? So I'll be taking you over to the drilling down of the harmonized effort of this digital forensic investigation. So I'll follow some of the steps because of standardization of the processes in digital forensic. So what we then going to do is we are going to detect the incident, go through the process of that we followed. And then, for example, the incident detection process, it was initiated by the bank when they saw unusual transactions that had occurred. And then from there, the first response was for them to, after identifying the problem, to freeze the affected customers' accounts for further to prevent further damage, right? So then the customers were conducted to verify the transactions, if they did the transaction or not. So then from there, we as the digital forensic team, after they approached us, we then laid out our planning guide, whereby we designed and developed a plan to guide us on how we're going to tackle this particular problem. So then from there, we did the preparation process. There are lots of softwares that are available, CoLab. We utilized Jupyter Lab for this particular incident, and then we followed the documentation processes as we collected the data from the bank, the transaction data, and then from there, what we did, then we actually hashed the data, and then we did the bitwise copy of the data so that we don't lose any other data set. And this is just an example of what we did. More of the information can be found under appendix. We then did analysis of the data. We applied multiple algorithms, and then we used k-means clustering for us to cluster the data sets to see the fraudulent activities and non-fraudulent. And then finally, what we then did was to recommend to the business what the bank should do further. We are pleased that the bank actually has an existing data digital forensic platform that can actually flag any unauthorized transactions. So then we actually recommended that they institute a multi-factor authentication for raw level security, and then also to implement a much stronger password, minimum 16 characters, so to avoid such incident of hacking, and then to conduct regular security audits on their systems, and then to strengthen their network. And finally, is to always go back to the affected customers and see if they can improve the password length to 16 minimum characters. So yeah, so that's basically it. All the information can be found in the appendix. Everything should be here, what we went through. And thank you so much for your time.
Thank you.